In this video, we'll talk about the quartiles, percentiles, and the deciles. So let's start with the quartiles. So these are the part of the measures of the central tendency and central averages, which are part of in the statistics. So let's start with continuation of the previous videos after mean, mode, median, and empirical relationship between median mode and median mean. So all these are also part of the central tendency. So let's start begin with the quartiles. So quarter itself indicates 4 quarters. So each represents 25%. So basically, these quartiles are used where your range data distribution falls into. For that properties, you will use generally a quartiles. It's in a 4 parts basically, but you end up calculating Q1, Q2, Q3, where you have formulas for Q1, Q2, Q3, and IQR you have interquartile range, whether it is a difference between the Q3 and Q1, where most of the spread above 50% will be lying in these 2 quarters, difference between in these 2 quarters. So let's go through what are the formulas and how to do this for group data and ungrouped data. So quartiles are values that divide data set into 4 parts, each containing 25% of data. Quartiles help to provide deeper understanding of the distribution of data insights which the central tendency is spread over. So first quarter Q1, so the median lower half of the data, it divides 25% of the data set, and second quartile is 50%, and the third quarter is again the median upper value, it divides into 25% of the data set. So IQR is in a range of the first and third quarter, where most of the spread is above 50%, up to 50% is spread. So let's understand how we use these formulas for an ungrouped data and a grouped data. So if a data set is given, how do you measure the quartile? So Q1 for first quartile, the formula is to remember is n plus 1 by 4. So where n is a number of data points. So 5 data points, if you have 5 plus 1 by 4 will become your first quartile. Similarly, second quartile. This is second quartile, or it is called median quartile. Whenever it is in the middle, you will call it as a median. So the median value, you know, right, how to calculate n plus 1 by 2. And the third quartile is nothing but 3 by 4 n plus 1. So 3 by 4 n plus 1 is your third quartile formula. For ungrouped data, these are the three formulas to calculate Q1, Q2, Q3. Then how do you interpret all these will come in your IQR. So let's move on. So what are the steps to calculate the quartiles for a given data set for an ungrouped data type? So first thing is, anything in entire statistics, you will arrange the data in the ascending order. Then find the median of Q2. Q2, you will find the median, just the middle value. Then you divide the Q2. After once you get the Q2 value, then you divide into upper limit and lower limit. That is, divide the data into 2 halves. Once the data, one data is first half and second data is second half. So find the first quarter. So you know the Q1 formula and you know the Q3 formula. You will find the first quarter and third quarter. Then you will interpret a IQR. So this is the steps to identify the ungrouped data for an given data set. So we'll see the examples once we understand the theory of percentiles and deciles, how we have done for previously for mean, arithmetic mean, harmonic mean, etc. How we have done, and a similar pattern will go. Next comes the ungrouped data. I'm sorry, grouped data. So grouped data means where you will have a say class interval and a frequency will be given. So for a class interval and a frequency is given, so how do you calculate a quartile for a group data? So L plus QK, K indicates here your values Q1, Q2, Q3. So if you are calculating for Q1, you will place the formula with Q1 and L plus N into K. K becomes your Q1. And similarly, Q2. You have a Q1, Q2, Q3 separately. And when you are doing that, your K represents your Q1, Q2, Q3 here. So QK is equal to L, as we know, lower bound value, which is L, and N is your total number of observations or summation of frequencies, total number of observations, and N into K. K is Q1 or Q2 or Q3 with respect to whichever you are deriving, and by 100 minus CF. So for how you go for a median cumulative frequency for quartiles also, you need to calculate the cumulative frequency. Cumulative frequency is nothing but you will add one after the other value. First value remains the same as per the frequency. So the keep on adding the values until your data set ends. And F is your frequency of quartile class. What is your frequency of the quartile class? That becomes your F, and H is a width of the class. So the difference between the interval will be your H. So next, how do you calculate for the ungrouped data for an grouped data, not ungrouped data. The heading is wrong here. For a grouped data, same. You have to prepare the frequency table, including the cumulative frequency. And cumulative frequency, you need to find for Q1, Q2, Q3, and identify the quarter class using cumulative frequency and apply the quartile formula. Whichever the formula we have put here, Q1, Q2, Q3. Instead of K places, you have to use 3 times. So I will show the example when we are doing it. So let's move on to the next slide, which is about the percentiles. So I hope everything is understood in the quartiles. Let's move on to the percentiles. Percentiles again. So in general, what are percentiles? So these are 1%. Generally, when a hike is given to any industry, yearly hike industry, you will consider the percentiles. How much percentage has been given? 5%, 10%, or 8%, or 7%. So like this, how many parts it will be there? It is 100 equal parts. So percentiles can be 100% I got it, or I got 50% hike, or something like that. You keep discussing, no? So this data distribution is done across 100 parts. Earlier in quartiles, we talked about only 4 parts. Here it is divided into 100. So percentiles are values that divide a data set into 100 equal parts, where each part represents 1% of the data percentile, are used to understand the relative standing of particular value in a data set. And they provide more detailed insights compared to quartiles. Quartiles, you are figuring out which quarter it comes. Is it under Q3 or Q2 or Q1? Whereas here you are going into deeper and give you the quartile values. So a specific value which is given percentile of data values. The 50th percentile of a median is it lies between 50%. So again, let's do with the ungrouped data. What is a ungrouped formula? P by 100 into n plus 1, where LP is a position of pth percentile of a order. For example, in your formula, if they ask you, please find the 60th or 30th or 21st percentile of that, then LP becomes your that percentile. And P, the desired percentile, 25, 50, 75, it becomes. And N is number of data points, and LP is, you can have any decimal or an integer for LP value. Is a not integer, interpolation is used to find the exact percentile value. How to identify interpolation, etc., all those will cover while doing the example. Okay. Next comes the ungrouped data. How to do the ungrouped data? So we took for grouped data for this formula, and for grouped data, we took this formula. For ungrouped data, we have this formula. So now same thing, arrange the order, percentiles to find, arrange them in the ascending order, find the position, and interpret the position. If it is an LP value is an integer, how do we calculate? And if LP is a decimal, you will, how do you interpolate that value to the closest value, you will find out. So the formula for ungrouped data is, again, LP is equal to K into N plus 1 by 100. So this is for, and the interpolation formula, if you observe here, there is PK is equal to XI plus D into XI plus 1 minus XI. So this I will explain during while narrating the example. Next comes your percentile for a grouped data. So, as usual, whenever you do for a group data, if a frequency is coming, like how you did for quartiles, cumulative frequency, you will follow the same for percentile also. You will end up doing cumulative frequency and frequency and lower bound and width class of the width you will identify. So now latest formula for the grouped data for percentile is PK is equal to L plus N into K by 100 minus CF. CF is cumulative frequency by frequency into H. N is total sum of the frequencies, and PK is the kth percentile, whichever percentile the problem is asked, you will identify. It could be P25th or it could be P20 or anything. And L is lower bounded percentile, N is the number of observations, and cumulative frequency of the class before the percentile. So you will identify the frequency first, which is where is a class that particular whichever class that particular frequency is lying there, and that corresponding cumulative frequency, you will take it as cumulative frequency and class width. This is about the percentiles. And how do you calculate, how do you organize the formula using the steps? So organize the data into an CF and calculate the cumulative frequency and find the corresponding class interval that contains the same formula you use here. Again, the heading for this is for ungrouped data, it is, which is wrong. This is for the grouped data. Okay, so the similar steps will be there, but only difference is you will find here, you will arrange the data in ascending order, whereas in your group data you will find the cumulative frequency when a class interval comes. So that's find a steps to identify for the percentiles to do it. Next comes your final topic in the central measures of central tendency, which is deciles. Again, see, we spoke about quartiles 4 and we spoke about percentiles, which are 100 parts divided. And when it comes to deciles, it's in a 10 parts. Basically, 10th, 20th, 30th, like that, you will decide into 10 parts. That is nothing but a deciles. Deciles are statistical concept used to divide data set into 10 equal parts or 10% intervals. Each decile represents 10% of the data. When it is arranged in the ascending order, this is particularly used in the fields like economics and finance and social sciences, which everything, meaning take anything percentiles or quartiles, most of the percentiles are used in the finances mostly, which what is your stock percentile returns or etc. You talk about this, no? These are all understanding where the distribution of the data on a particular period, how it is there, you will understand this. This is about deciles. So now let's move on to the deciles key points and how it is used and how do we do it. So basically, D1, D2, D2, D3, like that, it represents up to D10. So 10th decile includes the top 10% of data, and D1 represents the bottom 10%. So your top will become your D10 and lowest become your the D1. And similarly, D9 will become the ninth, and D2 will become the 20th percentile. Like that, it keeps on. So calculating again, same thing for group data, arrange it into the ascending order and divide it into 10 parts, equal parts, and cut off points and interpret that data. So where all it is used based on your income distribution, financial analysis, education system, social science, economics, everywhere these deciles are used. Once you have a data where the data distribution lies, you can identify. So now let's come back to the formula for the ungrouped data. So pk into k into n plus 1 by 10, and pk is again k, it can vary between the 1 to 9, 1 to 9, and n is the total number of values you have. And same steps 2 is ascending order, position, whichever you are calculating, find that, and if it is an integer, one value, if it is an a fractional or an a decimal value, how do we interpret? I will help you with the examples while explaining the examples on this deciles. And so here, integer position, how do you calculate? It is little in that step. This is given more detail. Same thing, ascending order. Example, fifth decile is taken. Interpret the position, interpolation when integer is given. So all these will cover. And next comes the uh, decimal position. For decimal position also, so interpretation, how you have the formula for the percentiles or percentiles. It is a different formula here. X plus, there we use di, here we use lp minus lower position into difference between values by 1. So the same thing, when interpreting the integer and decimal, we'll use this formula. How do we interpret everything, we'll talk in the deciles example. And grouped data, so again, whenever the grouped data for from median onwards, all these, when you talk about grouped data, when a class interval is given, you will talk about cumulative frequency. When you talk about mean, arithmetic mean or geometric mean or harmonic mean, you talk about midpoints when a class interval is given. So all these by default, CF will come. CF is nothing but cumulative frequency. Cumulative frequency are nothing but adding the value from the top to bottom frequencies. Keep on adding till your data set ends. And the formula here it goes is L is your lower bound, K is nothing but your kth decile. It could be from 1 to 9 decile by 10 minus CF, which is a cumulative frequency, and divided by frequency, the frequency whichever is the highest, and into H, class width. Okay, frequency of the decile, whichever class you are corresponding, will come into that. So this is about the decile formula for a grouped data. With this, we completed theoretical for explanation from the central tendency or averages, measures of the averages, central averages. All these concepts like mean, median, mode, percentile, quartile, and deciles. All these comes under our central tendency or measures of central tendency or measure of averages. So we have seen in the examples of mean, arithmetic mean, all in one session, and theory in this session on the deciles and percentiles. In the next video, you will see the examples of all the percentiles, quartiles, and deciles you will see. And overall, I will do one more session for the all the unique examples, like in the arithmetic mean, we didn't do for direct method we followed, but we did not show the example for the assume method. Similarly, for the geometric mean, we did with nth root of product of values. We did not do to the power of 1 by n or exponential value, something like that. So whichever are unique examples are there, I will cover it in a separate video apart from explaining these examples, so that entire chapter with unique examples and different examples will be completed with the next video. Okay.